Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is matrices. In this video we will be focusing on NCERT solutions for the miscellaneous problems. In the first problem we are given if A and B are symmetric matrices, we need to prove that AB minus BA is a skew symmetric matrix. So how do we proceed? Since A and B are symmetric matrices, A equal to A transpose and B equal to B transpose. Now we want to show this matrix AB minus BA as skew symmetric matrix. So we write AB minus BA transpose equal to AB transpose minus BA transpose. This is equal to B transpose A transpose minus A transpose B transpose. Since A equal to A transpose and B equal to B transpose, we can write this as BA minus AB or equal to minus AB minus BA. This is on the LHS we have AB minus BA transpose. Now when the transpose of a matrix is equal to negative of that matrix, then it is a skew symmetric matrix. Hence AB minus BA is a skew symmetric matrix. In the next problem we need to show that the matrix B dash AB is a symmetric or skew symmetric depending upon whether A is symmetric or A is skew symmetric. So we know from matrix multiplication is associative, that is X, Y, Z, say three matrices are there, its transpose will be Z transpose, Y transpose, X transpose. So let us start with the matrix B dash A B. Let it transpose B. So we can write from this side B transpose A transpose B transpose transpose, which is equal to B transpose A transpose B. This will be B. Now we'll do first case when A is symmetric. A is symmetric. So A will be A transpose. So this we call it as equation 1. So in this we substitute A equal to A transpose. So this will become B dash A B dash will be equal to B dash A B. So what we see? We see B dash AB transpose is equal to B dash AB. So the transpose of a matrix is equal to the matrix itself. So that is called as a symmetric matrix. So implies B dash A B dash is symmetric. Now in the second case A is skew symmetric. So what does it mean? Skew symmetric means A dash will be equal to minus A. So we substitute this in 1. Substitute this in 1. So we will get B dash AB dash equal to minus B dash AB. So again we see the transpose of this matrix is equal to negative of that matrix. So B dash AB is a skew symmetric matrix. In this problem we need to find the value of x, y, z for the matrix given as this, satisfying the condition A dash A equal to Y. So we substitute here A and A dash and this is the identity matrix. So A is this, A dash is transpose of this, changing rows into columns here. Each row is changed into columns here. This is the identity matrix. So A dash equal to I is given, so we multiply each of them. We know this row will be multiplied with this column element by element and then added up. Similarly, this row will be multiplied with this column for the second element, element by element, and then added up. Like that we proceed and get this as the final equation. This is again a diagonal matrix we see. So we since this equality symbol is there here, we can write 2x square equal to 1. So 2x square will be equal to 1. So this will give x equal to plus minus 1 by root 2. Now similarly 6y square will be equal to 1. So y will be equal to plus minus 1 by root 6. Similarly z will be plus minus 1 by square root of 3. So we evaluated all x, y and z. In this problem, a manufacturer has three products x, y, z which he sells in two markets. These are the two markets 1 and 2. So these are the annual sales. These are the annual sales. If unit sale price is given as this units for each of the products, then we need to find the total revenue with the help of matrix algebra. So we can write let matrix A be given by these numbers where the column represents the products. Each column represents the products and the rows represents the markets. Let B equal to the unit sale price for the three products 2.5, 1.5. This is given. Now to get total revenue, we multiply total sales by unit sale price. So we write like this. This is the total sales and this is the unit sale price. So we multiply them. Matrix multiplication. This row will be multiplying this column for the first element. Similarly, second row will be multiplying this column to get the second element, and this is done element by element. So this will be equal to 46,000 by 53,000. So this is for market 1, 46,000 is for market 1 and 53,000 is for market 2. That is the total revenue. Now in the second part we need to compute the gross profit. We know profit equal to total revenue minus cost. Revenue minus cost. Revenue already we have computed. We need to compute cost now. Then we can subtract like this. So cost price is given as for each product XYZ as 2, 1 and 0.5 respectively per unit. So we can get total cost as total sales into unit price. This is the total sales. This is the unit price. So we multiply and get the total cost in market 1 as 31,000 and total cost for market 2 as 36,000. Now profit is revenue minus cost. Revenue already computed in part A. So this we are taking cost from here and we subtract and get profit in market 1 as 15,000 and in market 2 as 17,000. We need to find the matrix X such that X into this matrix product is equal to this. So how do we proceed? How do we get X? So we know the size of this matrix is 2 by 3. Size of this matrix is 2 by 3. So when X has to multiply this, let X size be M into N. So For matrix compatibility, n must be equal to 2. So n must be equal to 2. If n is 2 and if product occurs, then this matrix is 2 into 3. So m into 3 will be equal to 2 by 3. So m also will be 2. The size of X matrix will be 2 by 2, or the order of the matrix is 2 by 2. Now we write that X matrix has some U V W X. So we are writing like this. So this means it is a 2 by 2 matrix which we want to determine, where UV represent columns and WX represents the second column. So we need to evaluate each UVWX. So now we do the matrix multiplication. Get equations like this: U plus 4W we equate it to minus 7, to U plus 5W minus 8. So we get this, and solve for UV and W and X. So we get U equal to 1, U equal to 1, V equal to minus 2, W equal to 2, X equal to 0. So we get X as 1 minus 2 to 0. In this problem we are given A equal to this matrix. We need to put it in this equation and find out what equalities we are getting. So this is a MCQ problem. So we write A into A equal to I given. So we write this matrix equal to identity matrix. We know how to multiply element by element. So alpha beta will be multiplying with alpha gamma. Similarly, alpha beta will multiply with beta alpha for the second element in the first row, and similarly the second row will multiply with first column and second column respectively. That's what we did here. These terms will get cancelled. We'll be left with this. So we can write alpha square plus beta y equal to 1. So this will be 1 minus alpha square minus beta y equal to 0. So option C is correct. Friends, with this we conclude this video. Please like and subscribe my channel so that in future more videos can be released to you instantaneously. Thank you very much, friends.